Okay, it's 8:30. We're supposed to get started. It seems like people still coming in. It's pretty early in the morning. Good morning, everybody, and welcome to EuroSciPy 2023. So that's number 15, 16. So it's quite a few EuroSciPys been held already. So I've been involved on all of them. My name is Mike Müller, and I will be your tutorial speaker this morning. We would like to dive a little bit deeper into JupyterLab. First, I introduce myself a little bit, and then I have a few questions about you. Then I know who's in the room. So I've been using Python since 1999. I bought my first book. At this time, everything was still on paper. In April 1999, I used Python version 1.52. Still remember this one was brand new at the time. And I've been using Python ever since, so I have a scientific background. I worked at a research institute and did my PhD, coupling numerical models. And so the whole thing started, and in 2004 I gave my first Python training, and ever since this thing's developed. And eventually in 2006 I founded Python Academy, and since 2010 I do it full-time. And I still do it, and we have quite a few other trainers teaching Python, so I spend most of my time trying to tell other people how to program. And that's why also I'm here, and I would like to tell you a little bit about JupyterLab, which is one of my main teaching tools I'm using. And all the other tutorials here very likely will use Jupyter or JupyterLab in one way or the other. Okay, a few questions about your Python skills. So who's programming Python 1 year or less? Please raise your hand. 1 year or less? A few people. Between 1 and 3 years? Or maybe 3 to 5? More than 5? Yeah, so it's also always a mixture between people. So who of you had used Jupyter notebooks before in one way or the other? So not everybody. So there's a lot of Jupyter around. There's quite a bit of history. I used JupyterLab, which is the latest version. There's still this older version, Jupyter Notebook, which is kind of merging with JupyterLab now in terms of source code at least. There are some historical steps involved in the thing. Therefore, there might be many different versions, but the principles are very similar. They haven't changed much. So in terms from the user perspective, things didn't change too much. They just re-implemented everything because the software had to be updated to current standards, and they learned a lot. Everything started with IPython, so we can have a quick look at IPython. So a lot of things actually I cover here are IPython features, and it doesn't really matter if it's IPython feature or JupyterLab feature, you use it anyway, but if you want to use IPython on the command line, it can be useful. Okay, please download this material. So I will, if you haven't done so, I will come back. It's a PDF with the material I cover here and a few source code files. Otherwise, I don't distribute any notebooks on purpose because I develop them here. So if you open this PDF, you will see this is the program we're going to have today. So if you go to the table of content, so we have IPython and Jupyter, or I can also go to the table of content here, it's a bit bigger. So I explain about IPython and Jupyter basics, and then also have something like more like best practice if you want use cases for notebooks and anti-use cases, because notebooks are not the best solution for everything. And as always, you have to use the right tool for the right purpose. And a few of these avoiding pitfalls, a few things going through. Okay, there are some exercises here. We only have 90 minutes, so we can already do the exercises. It will take like half an hour, so we don't have that much time, but otherwise you're welcome to do exercises. I do have a solution document, which I will distribute after this, so you can also, yeah. So this is a tinyURL JupyterLab 2023. So JupyterLab has been around for a while. So everything started with IPython many years ago. I don't know when, but more than 15 or something like this. So IPython is actually something you can type at the console, and so you get a much improved interactive prompt in Python. You have this REPL in Python with the 3 greater signs, and then you can work there. And this is not too comfortable. And IPython gives you a much nicer version that works in the terminal. And out of this this IPython notebooks developed, IPython notebooks, and then they called it Jupyter because Jupyter stands for Julia, Python, and R, I think, because it's a multi-language. Nowadays, there are at least 100 languages supported with so-called kernels. And then the latest version is JupyterLab, and there are still this used to be this parallel thing between the old traditional IPython Jupyter thing and or Jupyter Notebook, I was called the whole thing, and JupyterLab as a software, but they merged now. The term Jupyter Notebook is also used for the documents, for these files we use here. So everybody should have installed, if you don't have installed that, that's a bit late, so please install JupyterLab, which is important. So conda, it's on the web page, so conda install or pip install JupyterLab should do it. And quickly I go through the GUI a little bit, not very difficult. So if you open this here on the left-hand side, you see we do have a file view here. These are some files. I have a bunch of more files than you have. So if you unzip the zip file and you download, then you will see these files here. This is like a traditional Explorer kind of thing. You have your files. Then you have something called kernels. This round thing, this is how the whole thing works. So you have a kernel in the background. That's why I'm on local host. Yeah. So theoretically, you can run this over a network. You have to be careful, it has to be safe. So if you want to do this, typically Jupyter Hub is a way to do it. Jupyter Hub gives you something in front of JupyterLab, so you can log in, you have an account and things like this. This one has to be set up. We don't have this here. We just use plain JupyterLab. And these kernels you see, this notebook I wrote this information in, has this extension, IPython notebook, this extension, and comes up here. But the other things also run in kernels. The console, we don't use consoles much. Consoles are just interactive prompts, and you can do some very sophisticated math. Big enough? Maybe a little bit bigger. Yeah. So, and if you just press Enter, usually nothing happens. You have to press Shift Enter, which is the normal way to execute things. So, I think you can change this. There's a lot of settings you can change this, but Shift Enter is a standard to execute things. Yeah. There's also terminals around and a few other things. Here we have a table of content we don't have yet because this would be these ones. You see this is a table of content of this notebook document, and there's extensions. Here there's a bunch of extensions you can install that extends the functionality of your notebook. I have pigments here for syntax highlighting. You can have a spell checker and many other things. Most of the time you look at this view. So this is a directory on my computer, as you might see somewhere here in my home directory. You cannot get out of this, but you can go below. So if you have to always start at the highest prompt. So if you type JupyterLab, so to get started. So let's do this. So you have to install. The people are still coming in. Install with either Conda or Mamba, install JupyterLab as one word, JupyterLab as one word, or alternatively pip install the same thing. Yeah, so that would work, and you install it, and then you start it with. So you see now I use this JupyterLab and I use it already, and I changed the cell up here. So typically you have two code cells. Those gray areas are cells where you can execute arbitrary code, or you can turn them into Markdown. Who knows Markdown? Yeah, some people. So Markdown is a simplified markup language, and you can use this Markdown language. And as you can see, when I indent 4 spaces, then and I execute it, then the commands become monospaced, which is a typical thing for command. There are other things you can use backticks or other means to present code. This would be installation, and then starting would be on the command line. When you have everything there, you type Jupyter-lab, Jupyter space or -lab. Both of them should work. Yeah. Then you start it, and then it starts at localhost and runs at localhost. So theoretically, everything can run over internet, but then you are responsible to make it secure, run into some kind of tunnel or whatever you want to do with it. That's totally fine. Jupyter Hub is one way of doing this. So you can do a lot of things with these notebooks. Typically, the main purpose is discovering things. learning things, learning new things, learning short snippets of code to see how things work. If you develop bigger software projects, then you typically won't do it in a notebook. And there's many other tools that can help you. So if you go to a terminal, then this is a terminal, one of the terminals. So if you don't have a terminal, you always can start, when you open this, you start with this view here. And you see here you have multiple buttons. You can click a terminal or you can open a notebook, which we do in a minute. If you click on terminal, then a terminal opens. And in the terminal, you can type IPython. And this gives you the additional IPython version. It should be, it doesn't work. Mine doesn't work because I have to activate my environment, and then I type IPython. It should work. And you have IPython. So I used Jupyter 4, which is the newest version. It came out just a few weeks ago, I think. Doesn't look very different for the user, at least with my experience, but underneath the hood, there's a lot of new things in Jupyter 4. And you have your IPython, and somehow this auto-completion you see. Now you can do the same thing in here, and this runs on the terminal, so you can use IPython over SSH or other means, and everything gets nice and colorful, and you get a lot of features we see in the notebook also work on the terminal. A few things don't work because there's no Markdown, obviously, yeah, and a few other things don't exist. Graphics don't work the same, like matplotlib and some things. They cannot be displayed on the terminal. You need to have some other backend to display these things, but otherwise a lot of the tools we will learn work in the notebook. Everybody has a thing running. Anybody needs help, so everything fine? Let me know if something goes. Shift-Enter? Shift-Enter is to execute. So let's do notebook. So this would be the IPython. We don't use IPython much here because everything you can do in IPython you can do in a notebook, so that will cover it. So if you go to this blue plus, you get the launcher. There's also a lot of menus here. We will discover some of them later on. So if you double click on this IPython kernel here, then you get what's called a notebook. And the first thing what you see here is maybe I make a bit bigger, we still have some space, is the terms untitled. Fortunately, when you want to save it, just Control S. Once to save it, then it prompts you to change the name. Please always change the untitled name to something useful. So something like Jupyter, which is not much better, but it is something that you can turn this off, but I think it's a good feature. I see a lot of people have untitled 1, 2, 3, 4, 5 to 17. What does it mean? Yeah, so rename it, then you have a better name. And now you can execute Python 1+1, and if you press Enter, you get just a new line. If you press Shift Enter, then you need to do this. So now if you forget this, you can write a note. So you change your code to Markdown. Yeah, you can do it with the mouse. For pretty much everything you can do with the mouse, or most of the things, there are keyboard shortcuts. Like Escape M would turn on a Markdown cell. And then you can write it down. Execute cell. I typed something strange. Execute cell. Yeah. And now you can write your command here, 1, 2, 3, 4. And then you can have a Shift plus Enter. Yeah, the Markdown is up here. Markdown, I will come to this in a second. Shift Enter. Yeah, and this is now the command. So it's always, that's why it's called a notebook. You can always take notes. So if something that say, just ask you a question, would I remember this in 6 months? If you say yes, you don't have to write it down. If you say likely no, then write it down. Very easy. Yeah, and next time you still have to find it somewhere, but at least you have written it down and you know how things work. So these are the two different types of cells we have here. And the Markdown, so if you don't know anything about Markdown, you go to Help. So the Help menu gives you all kind of help. And there's a Markdown reference. Yeah, here's a Markdown. Help should also show the Python help, so there's something, maybe I have to open yet another one. So, but if you go to this help, then it opens a new tab with the help about Markdown, and these are the basics of the Markdown. You know, Markdown is a simplified markup language, and then you see if you write asterisks around a word, you get an italic word, you write two, you get a bold one, and so on. Important one are headings, so the number of these hashtags determines the heading. 1 is heading first order, 2 second order, up to 6. Yeah. You can also add links, which is interesting. So you can create a link to some interesting Wikipedia article you want to find later on, or a YouTube video about something. You can also include images with this thing. You have to give it a URL, and a few other things like bullet lists can be very useful. You can number lists, and you can have this inline code. So if you use a backtick, then you get this monospaced writing with gray background, which means you have a command. Alternatively, as I did, you can just indent 4 spaces, then you also get monospaced. So these are alternatives. These are the basics. If you want to know more, you can look at one of these. Unfortunately, there's a lot of dialects of Markdown, so you'll find something somewhere that might not work in notebooks. There are also extensions. A pretty new one is Mist, which is an extension of Markdown that gives a lot of new features. When you write a book, Markdown is not good enough. And Mist gives a lot of features that are similar to restructured text, if you know this. So this would be an extension. These extensions work in notebooks, but we don't cover them here because it would be a whole own tutorial. Good, these are the basics. What you can do. Let's go to some of the functionality that comes from IPython, and IPython gives you these magics. And one of the magics is the %. If you write a % sign, then you get magics, magic functions or magic commands. And then when you type some letter and tab, always a tab gives you tab completion. So if you have the tab, you get tab completion. And then if you say quick ref, you get a quick help of all these things. All these magics work in IPython also. And you will see there's quite a few magics here, and we will cover some of them, not all of them, but some of them that can be useful. So if you go through, you find quite a few of these things. So one thing, if this gets too big, but you don't want to delete it, you can say clear outputs, clear cell output. It's called now, and then it should clear the cell output. Why doesn't it clear the cell output? So it should say clear. No, clear outputs, yeah. Then you still get a command, and then it's, but the outputs are gone. You see, all the cells are numbered. These are the code cells are numbered. The Markdown cells are not numbered. And you see now I have here number 1 and the head number 2. If I go back here and I re-execute the cell with Shift Enter, now the cell becomes cell number 3. So the cell number 1 is not displayed anymore, but the effect that cell number 1 has is still there. In this case, it doesn't have any effect because 1 plus 1 creates a 2, and we don't store the 2 anywhere, though the 2 is gone. But this is an important feature of notebooks and also an important pitfall. You can jump back and forth between cells and execute them in any way. So the display order is not necessarily the execution order. That can be a problem. And this can trick yourself. I tricked myself many times. But there's always a solution to this. One of them would be going to kernel. Yeah, there's two things. The kernel runs on the server, and I'm in the client in my notebook. In this case, it's on the same machine, but the kernel can be on a different machine. That doesn't have to be there. And then you have many options what you can do, and one of them I use a lot is restart kernel run all cells. And this one, say now I'm restarting the Python process because I'm in a running Python process, which can have sometimes strange effects if you're not used to importing and all kind of stuff. Yeah. And then if I say restart, it restarts everything and runs everything, and now my cell is numbered again with 1 and 2, and or potentially strange effects are gone. So this is important to remember that you It doesn't work the first time. This is so strange. So I didn't have this affected. So the menu was called clear all output, clear outputs, and clear output. Why doesn't it work? So alternatively, you can write in the Markdown cell so I write this command here. So it's in Markdown, it's not executed, but you still remember the command. So now I can also import things. So tab always gives me tab completion. This tab completion is basic. You can also install extensions that improve this tab completion in many ways. So there's a lot of extensions you can install. It's usually pretty easy if you go over here and type an extension you want, something like this, then it's going to search for an extension and gives you something like this language server protocol, which is one extension that would improve the tab completion. But we do have tab completion. If you put a question mark, you do get a help. So this question mark is different. It's not standard Python syntax, but you get help, and now you get a help about the OS module, and you can find out things you want. If you put two question marks, then in addition to the help, Python tries to display the source code, which it does here. It's pretty big, so I don't know why it jumps so. Typically it stays on top. So two question marks gives you the source code if available. If this is a module written in C, you don't see it. But this OS is written in Python, and now you see this is a Python source code of this file, and you see the source code with syntax highlighting, and this can be useful. Good. All the things work on command line. Some important magic commands. One of them is ls. ls gives you the output of the command ls. This is equivalent to the bash command. The nice thing is ls also works on Windows, because in Windows typically it's translated to dir. So when you switch between operating systems, I often find myself typing ls in Windows and it doesn't work. And here you have a way to have this ls. And you can also, if you really want to say, you can harvest the result, and now result, no, this one doesn't work. So, this one doesn't work if you wanted with a story. Alternatively, you can use exclamation mark ls. This works because I'm on a Mac, so I have bash or set shell installed. That's why it works. So if you do this in Windows, it wouldn't work. But if you do this now, I should be able to, hopefully it used to work. I can harvest this one, what's coming back, and now I can access it. And you see, it's actually nicely formatted as a list. So it's always preferable to use a % version if you can, because now it's platform independent. If you use the exclamation mark, then your notebook is potentially only works on some platforms, and if somebody runs this thing on Windows, it says there's no such thing as ls unless you have ls working, which is possible on Windows for sure, but not per default. So you can also have some useful commands like less, so we can look in our notebook itself, and this is, so that it jumps to the end, it's new, so I have to say, I didn't have this before. Typically it's just shows you the first cell, which is now a little bit strange. There's a new feature of the new version. So if you say less, it uses the pager, and now we can see this Jupyter file, and see this Jupyter notebook file is just JSON. So JSON is a file format, it's human readable. So if you want to, you can actually look inside your Jupyter notebook. And also, it's pretty easy to parse this thing with just JSON load. You can load the whole notebook into a data structure, into a dictionary of dictionaries and lists, and you can work with your notebook in a different way. So see, yeah, now it works, and it turns off the display. So you can also use ls directly like this. So if you say ls and ls doesn't exist, Python will go for the %ls, which could be a problem if I assign ls, it doesn't work anymore, so it changes behavior. So it's always recommended to use a %sign. Don't rely on the feature that IPython will look for the % name, because if you by accident define it, then all of a sudden the behavior of the notebook changes. But so there's a few basic ones you can go through. You can also look at the aliases. So if you're interested how things look behind the scene, these commands exist. Here, if you do this in Windows, you will see a slightly different list because the aliases are different. You see there's a lot of these ls aliases with different colors and different kind of features. So you need to, if you want to know what it means, you have to look it up on the menu, on the main page, what all these options mean, what this is doing. So it's running it through grep and other tools. So many of them have the same name. Yeah, on Windows, ls is just a dir. Typically, unless you're on PowerShell, so Windows PowerShell does have an ls, then we'll use ls of the PowerShell. You can also actually define your own command if you like. So you can add your own command to aliases if you want. This would be platform dependent. So if you want to do this, you can say alias. So the same thing applies here. If you don't know how alias works, you use a question mark, and then it tells you everything what alias is doing. So you get a doc string, and they have an explanation, and typically they also have explained the command line arguments here, so it's a longer help how this alias works. And I can define a new alias, my command, yeah, and then I could say do something like cd into this subdirectory, and then play ls, and then I have multiple commands. So I use a semicolon here. If you do this in Windows, you have to use an ampersand. It doesn't work, and so I come back up here. And if I execute this one, now I can use my command. So if I type, you see now my command comes up as one of these commands, and now it's doing multiple things. It goes down into subdirectory, displays, and comes up. It's not really necessary. You can do that directly, but this is now, if you have things that are more complicated, you can define your own aliases and have them. If you restart, you see it's gone, so it's only in the notebook. If you want it to survive, you have to write it in your startup file. There's a RC file where you can put things in. I think IPython asks things. If your home directory, then you can put this command in and it will be executed all the time. Good. You can also use bookmarks. There's one interesting thing you can use a bookmark. So if you find yourself, yeah, bookmark L or -L, -L, lists all the bookmarks, so you can specify short names for long paths. So if you find yourself a lot changing between paths, then you can find a bookmark, and then you don't have to remember the gigantic path. And those bookmarks survive. If you see, I have a bookmark that that is here already, so I can have a bookmark home if you want, and then I can just specify to home, and now it points to my current directory. You can also give it a directory to bookmark, and then you can bookmark. You see, now this is my my directory where I put the tutorial. Yeah. Excuse me?
The contextual menu. If I type %bookmark.
Yeah, %, you type %, and then you %tab, and then.
I do not have the menus which are displayed.
The tab key. The tab key, tab. The key and with an arrow on the left, the tab. Tabulator key. The tabulator key should give you the help. The tabulator key gives you the help. Yeah, so since you're in the browser, so some browsers might behave differently. Sometimes it happens if you have a Chrome-based browser or Firefox or Safari, there might be slight differences in behavior. It's not that much, but sometimes a few things don't work that nicely. For instance, if you have a Markdown cell here, then I could do something like this, and if I press Tab, it doesn't work anymore. Do you have the wrong? No, just as a. How do I get the change keyboards now? This is a Markdown cell, and now if I press Tab, it doesn't do it. It used to expand it to pi, the Greek letter, and it doesn't work anymore. It used to work, so maybe it's a. It's a Chrome-based browser I'm using here. This one would be helpful, so you can use LaTeX notation for things. Maybe somebody can try, if you type this in the tab, it should expand to pi. It used to be, yeah, but it doesn't work anymore, which is unfortunate. I'm not sure why. So I haven't tried this newest version with all the features. I just assumed that would be the same, but obviously it's not. Maybe something changed with the browser also. Sometimes this happens. Then it's unfortunate. So I can use push, yeah, and now I can say I want to go to temp. Now I change the directory, and now I have a list of directories. This would be the workflow. This would be a %sign. This is a workflow when you need to change directories often. Then you can have like breadcrumbs, like a history of things you want to go. Now you can say % push, and I say home. Now I go back home, and see now I'm back home, and I have if I want to, I can now go back, and I say pop, and this one goes back exactly the same way, and I can go back the same way. So this is a workflow. Somebody would have this thing where you change directories in a certain order, and when you go back exactly the same way, then you have this. There's a bunch of more of these important ones that could be used, like you can get your current working directory, yeah, current working directory. You can get the history, yeah. So these are the history of all the paths I visited, directory history. So if you say, this file was somewhere, I've forgotten where it was, then maybe this can be helpful that you can at least have an idea. So I changed only back and forth between these two all the time. But if you have a longer one, then you can go there. You can also look at environmental variables, many more of these things. Good. So if I have different names, so I define names here. Just check time. Then as soon as I start typing, you see now I get the completion, and the more I type, then the completion will be narrowed down, and everything that seems to make sense in context is displayed. Sometimes things don't make context. So non-local doesn't make sense outside of a function. So it's not that smart to know this, that non-local here wouldn't work at all. And also if I type, it also completes file names, which can be very nice. If you have a complex, so you cannot mistype a file because it gives you a suggestion. If the name is long, then it's nice to have this completion. Of course, you have to be careful. Some of them don't make sense. It's just a suggestion. You still have to judge if you need anything. So you can do this, and it can be useful, like if you define a list. If I define a list, and then I can say list tab, and I get all the methods. So it doesn't show the underscore ones unless I do ask for it. If I type underscores, then it shows you this. It's called dunder, the double underscore ones. These are kind of internal methods, which usually you don't want to see them because you don't call them directly in most of the cases, and therefore not shown. But if you want, you get them displayed per default, just a tab. They are not there, they are all this. Things. So if you want to know what happened, then you can say history, and you get the history of everything I typed. And I see that's everything I did so far in my session. When I restart the kernel, then history will be empty. This is just what's in memory. But it can be useful if you, because I can delete a cell if I want to. I can delete a cell. There's something you shouldn't do, but you can. So I can say x is 100, yeah? And now we have x, and now I can go here, and I can delete the cell. You can say delete cell, or you see there's also keyboard shortcuts, escape DD. Yeah, so if you use Vim, then you know the DD thing. Delete, because this destructive command, you have to repeat it. So if you say delete the cell, now the cell is gone, but the X is still there. So there's no visual hint what the X is. Yeah, it's gone. It's kind of magic. It's still there. Yeah, the solution. So now we can look at it. We can look at the input history. Underscore input history is a list. It's a pretty long list. So it's a long list. So we don't have to show this whole thing. It's a pretty long list. So if I just want to show the last 4 things I typed, you see that's the last 4 things I typed. It's a list of strings for all the input cells I did. For every, not the markdown cells, only the gray cells. And if I use not -4, -10, and you see here somewhere, you see that this one is still valid. Now, if I rerun the whole notebook, then you will see the X gives you an error. So if I say kernel, restart run all cells, which is something you do quite frequently if you work for a while, and then you see now I get an error message to say there's no such thing as X. Yeah? Makes sense that you get this error message. See, now it stops here. It stops here, and it doesn't continue. So you can say, okay, kernel no run. You see run, and you can say a run selected cell and all below. That would be useful. Then it runs the cell just to stop at the next one. If you don't want this, you can actually go here, and you have common tools. You can add a tag. So you can add a tag, and this tag is called races. I forgot the name, races exception. I have to check, I forgot myself, race. You can tag it and then it will be executed. I forgot the name of the tag, race exception. Just try races. I don't think it's going to work. But if you use your right tag, then this one would be executed when you rerun the whole thing. I have to check this. I think maybe I have to written somewhere. I forgot. I used it many times and I forgot exact syntax. I think race, maybe something can Google race exception. I think it's a tag. So these tags can be useful. These are metadata you can add to the cells. So if you look inside, if you have advanced tools, then you see it's just an entry in the JSON, and then this cell will be treated differently. That can be very useful. So you can add tags and you can use any kind of string, and then you can work on this JSON yourself. It could be pretty useful. I think race exception, I think it's yeah. Yeah, so that's one main thing. You can delete cells, then the cell is not displayed anymore, but everything is still in the kernel. Because we have this thing, we have a client which displays what you see, and you have the kernel that actually executing. So in the kernel, the X is still alive, it's still there, but you don't see the cell anymore where to find the X. You can delete all the cells, the kernel is still there. It's not recommended because it's very confusing, and one solution is just restart the kernel. So when you restart the kernel, run all cells, you synchronize the kernel and the display. And then you will get exceptions. So very often you get error message, you have no idea, what does it mean? It doesn't make any sense. But the first thing you do, you rerun the kernel, and very often many of these error messages just go away. Or they turn into error messages make sense, like X is not defined. Yeah, because all of a sudden it says X cannot do this and this because you defined it up there and you don't have the cell anymore and you think X is something else, but you did a typo. Yeah, you have 2 different names and you think you have this name, but a slightly different name which you don't see anymore is somewhere else. And then when you rerun the kernel, then you see an error message that makes sense. Yeah, so you can also tag. I think race exception. I have to check it, so I just made this up here. But then when you say run over, then for educational purpose, sometimes you want the exceptions to be executed. Normally, an exception means something is wrong and you have to fix it. Yeah, but like here, I want to show you there's an exception. Therefore, I want to execute. Now the length is different. Used to be 32. Now it's only 39 is 32 because I deleted some cells, so the input history is different. And you see, this long thing is my percent. When I typed in percent something, the history, this one gets translated into this Python. So whenever IPython sees a percent something, it says, oh, get IPython, run this line magic, and throw in the string and do something. So if you want to, you can use those magics in a normal program. You have to get IPython, you have to initialize a kernel. So there are a few steps to do, but then you can use this magics, which can be useful because some of them are very nice and can be useful outside of notebooks also. Okay, this is the input history. You also have the output history. The output history is not a list, it's a dictionary, because not all cells necessarily have an output. Yeah? If you have an expression, then you have an output. If you have a statement, you don't have an output. What's the difference between statement and expression? I don't need a 2-page definition, just one word. It's a big difference. So is this a statement or an expression? Statement or expression? Expression. Why is an expression?
Statements are part of the length.
Yeah, but this returns a result. You see in here, if it's an expression, 1 + 1 gives you 2. They have a blue and a red 34. That's the in and that's the out. If I say import OS, so let's say sys. Let's say sys is not there. If I say import sys, and now sys is defined. This is a statement. This is an import statement. See, there's only a 36. There's no 2 36s. It's just in. So this changes the state of your system in terms of my notebook. And this is a statement. And this is an expression. And this 36 doesn't have an output and therefore doesn't appear an output. So this is a dictionary. So if you want to see only the keys, you only call the keys. And you see now there's a 34 and a 37, but no 36 because this is a statement. And this one is an error message. Also, there's no output. So therefore, the input is a list. The output is a dictionary. And everything is numbered. And of course, the first entry in the list is empty. Of course, we start counting this 1, not the 0. And to make this indexing first, so if you have your input history, and you look at the first 3, then you see the first one is always empty because there's no 0 cell. Yeah, so people typically start counting this 1, not the 0. That's why the first one is empty. And now the index of the list is the number of the cell. Well, this can be useful just in case you forgot something. And you can also, if you want to have the input history of number 8, then this is what I typed. So underscore number gives is the same thing as so you can say. I don't know what I did here. It's the same thing as using the index 8. No? Why is it not the same thing? It would be the same thing. Yeah, that's output. You have to put an I. Yeah, so if you put an I in front of it, then it's the same thing as input history A. So, good. Okay, let's load something. I can say load. Oh no, we are not loading. We have to define something first. I define a function. That's one of my favorite functions, always define. Sure. And now I have this function, and I want to save this function. And now I can say save. And now I forgot how to use save. I use a question mark. And then it tells you a few things. You see, this is like command line options, and you can have a lot of these command line options. And it requires a file name, and it requires the history, so the number. So in this case, it wants to have the 40 to 43. So I can say save add .py, that's the file name, and I want to have 43 saved, and now it saves number 43. So this hardwiring 43 is usually not a good idea. because whenever you re-execute it, the numbers might change and it doesn't work anymore. So you have to find out a way. But this is just for interactive work. Instead of copy pasting, you can save it, and now you have this saved. And if you look inside this one, then you see this. It adds coding UTF-8, which is the standard in Python 3. Yeah, but it's still a good thing because now if you open an editor, the editor, yeah.
Can you save at I-1?
Yeah, you can say save, and then you use the input history. Save. I have to do this. I'll go here, and you have to say save underscore. No, this wasn't work. You have to say input. As far as I know, you have to say something like this. That should work. Now you have to say it override. Yes. So if I not shift enter, only enter. Yeah, and now it override. Yeah. And now I edit it. So I changed my file, and I have. What did I do? Shouldn't it be? Yeah, -2, because -1 is that's myself. And now we can say force to override the whole thing, so it doesn't ask. Why is still? Yeah. The F has to go. The F has to go there. Yeah. As first thing. So once you do the right, and now when I have to re-execute the cells. You see, that's not that easy. It's, you always get it wrong, especially when you do live coding. But that's possible, and you have to -2 because -1 it's the cell itself. The cell exists before this is executed. So this is always the question. So now you can use less to display it, but you can also use load, and load loads the whole thing into a cell, and now this thing is loaded, but it's not executed yet. You have to execute it to make it to execute the things, because it just loads the content of the file, and now you execute it. This could be useful. Yeah? I do this quite a bit when I demonstrate. So I load the whole file into a cell instead of opening it and doing copy paste. The load is doing this directly. I'm not sure if you can specify something with a load. Yeah. So this is a help. Options, they have some options, and you can specify the lines you want to load and a few other things. Yeah, you can also specify only a function and so on. So you have to read this. There's very often a lot of options here, and most of the time a load was good enough for me, so I don't know all these options, but they're always just a question mark away, and then you know how this works. Yeah. So if it's very big, yeah, 200,000 characters, you might not want to load the gigantic file in a notebook. Like don't load a 10 gigabyte file in a notebook. That's not going to end well. Even have a lot of memory.
You did not create a module, right?
No. This is just a copy, and it's like opening the file in the editor and copying it into the cell. The load. There's nothing else created. It's just text. Excuse me? Yes, you can save something in a file and then open the file in another notebook if you want. But easier is to import it. So I wouldn't. So if you want to use it, you just say import. This would be the most sensible way. So in this case, the import works because my add. Now I have my add, yeah, which should give me the right result. This would be the nicest way. And then if you make it nice, now it only works because in the same directory. Then you have to put it in the right place where in the Python path that it can be found and so on. That still works. Yeah, this is a preferred way of sharing things. Yeah, that's a good thing. Whenever things get big and you find yourself copying, pasting things around, consider moving things out into a file. Consider moving. So if you can do this by hand, if you don't like the same thing because it's not really nice, you just copy this, and then you can say file new, which is the same as a launcher, and you open the Python file, and then I copy this in, and I save my file, add to, and there you go. Yeah, and then you can import it and you work with it. You're not restricted to stack with a notebook. You can always go to the editor, and you can use Visual Studio Code, PyCharm, or whatever means you want, and you can combine it. Yeah, question?
When I write import add, I have the message no more use.
Yeah, so it only works because I put it there. So since I use the save command here, since I used this save thing, and I gave this the name add.py, then so if it's not there, you can always check. How do you check? You just say %ls, and then you see all those files. And if you want to restrict it, you can also say it .py. Yeah, and now it shows only the .py files, and the add should show up. And if it doesn't show up, you cannot import it. Yeah, that doesn't work. Yeah, so this is something you intuitively, if you know how ls works, you just use ls, and if you've forgotten, ls question mark should give you the help. And then now it's just, since it's an alias for this command, and it's ls, now it takes all the options ls takes. Yeah, so this is something now you have to find out what is ls. And these options might be different depending on your platform, yeah, because dir takes few options, ls takes near the whole alphabet as options to do something. Good. Let's look at error handling. So for this one, I have, so if you download the zip file, you get, how long do we have till? 10 o'clock, not much. So I have a small program that has a bug. So I divide x by y, and you see here, this is a function that x by y, and then I set the y to 0, which gives you divided by 0 error. Yeah? So this is if name equals main. So this checks for the name of the program. So if you check for name, then you see the name is main. So this is the same thing as running a program in a terminal, then the name is main. When you import it, the name is different. If I have my add, and you look at the name, then the name is add. If I run this program with Python add.py, then the name changes to main. So that means, it's a bit strange, but this means this program can serve as a library. Sorry, my mouse is very sensitive here. Can serve as a library, so I can import it, or I can run it as a own program. That's the thing. And now if I run this one here, then I get an exception, and you see you get an exception. And if you compare this one with the standard exception, you see already this is more exceptions, more information, because you get the line numbers and you get the context. So the notebook provides something called an X mode. So, and if I run this program again, if I have this, I should be able now. This should be the test function should be there, because it's, yeah. If I run test again, I can create the same exception. And see, now I changed the mode to verbose. And verbose now not only shows me the line numbers, it shows also the local variables. In this case, I only have 2. And this can be very useful, because now it displays the y0, which is the solution to my problem. This is a very small program. Yeah. If the program gets bigger, those bugs can be very difficult to trace. And seeing the local variables can be very useful. If you don't like this, you can always change the X mode. This toggles through the different modes. And this would be minimal. So if you have minimal, then this is very, very minimal, but it's good like for teaching. If I just show, okay, now that will be an exception, and I don't care for all this traceback, because people get confused with all this many lines of stuff. They, okay, this will be always an exception. That can be useful. You can always provide the mode, yeah, and then you can have those 4 modes. Plain is a standard Python one. Context is a standard notebook one, and the others are you didn't see? It just you either just you say X mode and toggle through, or you can write it out, and then it changes the mode. One of these 4 is allowed. If you provide the name, then it changes directly. If not, it goes to the next, and it was toggles around in this different one. So now this would be the standard Python one minus the color. You see, this would be the standard output, but if you have the line numbers, typically it's much nicer. The problem, if you have a both and you have a big program, there can be many pages of traceback. It can be very long if you program. Especially if you have a big dictionary with numbers, shows a whole dictionary. So it might be a bit overwhelming there. If you have to decide if you want it or not.
Sorry, what was the difference between context and verbose?
Yeah. No, the verbose, this one, these things are not there. This shows you the local variables. If you look in context, you don't see this one. Yeah? So if you have a big dictionary, that would show the whole content of the dictionary in there. It shows the local and the global verbs. I don't have much here, the local verbs in this case. Yeah? But if you have a more complicated thing, then you can see a lot of data. It might be too much because you get lost in all this amount of stuff. So if I have my exception, now I can say debug. And now it jumps into the debugger. So post-mortem, everything is done already, but now it jumps into the debugger right at the place where the exception is. And now I can check for the values. I can say, give me the value of X and give me the value of Y. And I can use IPDB to step through. So it's a basic command line debugger, yeah, but you don't have to go and set a breakpoint first. You just run your program. Whenever you have exception, you can just write at the place where the exception is. And then you have to know the commands quit. Gives you out. So there's a list of commands in the PDF. If you have a variable name with a name Q that doesn't work, you have to use exclamation mark Q to get the value of Q, because Q is a command. So you have to escape the commands, but it's just a handful of commands. It's not very powerful. There's a new one. It's called the debugger here, but for this debugger you need to run a different kernel. But this would be a nice visual debugger which is in here. So I haven't actually used it. Most of the time, this one, if you work interactively, it's good enough, but you can also have a more visual debugger, which would be a whole thing. So this is debugging, can be useful. Another thing is runtime measurement, one of my favorites. So I can use timeIt. Yeah? There's a %timeIt, which uses the built-in module time. There's a module in Python standard library, it's called timeIt, that is directly designed to measure runtimes. So measuring runtimes is complicated, and your measurements are always wrong. It's just a question how wrong they are, and they're never totally exact, especially if the times are short. If you measure something that takes 30 seconds, no problem. If you measure something like 1 + 1, see, my new M1 is very fast. If you measure something like 1 + 1, then measuring 4 nanoseconds is very difficult. You cannot just do it like this. Solution: here, you don't do it one time, you do it 100 million times. Yeah? So this number is determined automatically, so that one measurement more or less takes 1 second. So they always go 100 million, 10 million, 1 million, whatever. So if you take something that takes a second and you run it 100 million times, it takes you 3 years or so you don't want to wait 3 years till you have the result, so it doesn't work. So they run it only for once then, if it takes a second. And then they repeat, then of course they divide the time by 100 million, and then they repeat the process 7 times, and then they give you a mean and a standard deviation. Yeah, this is a mean of 7 runs, and if the standard deviation is small compared to the mean, then it tells you all 7 measurements are very similar. If the standard deviation is big, there's something wrong. If the standard deviation is very high, usually you get a message and say one measurement took much longer than the others, and this is very often due to cache effect. So the first time you do something, Python has to load the data into the cache, and next time the data is in cache is much faster. This is very specific to your processor, architecture, memory, all kinds of things. So this is pretty complicated, but at least tells you there's differences between measurements, and this is something you have to investigate. Yeah, it doesn't solve the problem for you, but at least you know there is a problem. Here it's not a big problem because it's very small, because 1 + 1 is very quick and everything is just, those things don't get loaded from memory back and forth, they just stay at a processor, and that's why you get this one. Yeah, and then this is always my benchmark. See, this is now an ARM64 environment. If you run the same thing on this computer with not an ARM environment, then it takes about twice as much, and my old computer was about 60 nanoseconds. Yeah, so that means my computer now is 4 times faster than the old ones, at least for my standard time. It's 1 + 1 here, that is doing something. So I do have, I do have 2 very stupid functions here that create I know this is easy. This is an academic example. Now this is two functions. These are two functions that create a list in reverse order. So per default, both of them create a 10,000 long element list. Here I start with an empty list, and I go through this n, and I insert at the position 0. So always at the first one I insert there, and I create the list, and the other one it produces exactly the same result, looks very same thing, only I append, and then the list is in the wrong order, and I reverses at the end. Yeah. So if I do this and I compare the results, insert 0, append reverse, then I do get the same result. And if I say insert 0, so this gives me a long list. Yeah. So that's why I want to see only the first 10. And you see this would be those numbers backwards. So, of course, you can say range, start, end, and turn into list. This would be even more efficient, but this is just an example. And now I can time it, and I can say %time it. And actually what I want to keep the result. So I can now save this as a result, and I can say insert 0. And if I do this one, I have to yeah, I can use time, but I use time it here, and I have to specify the option O that gives me so I should call this one time 0 or something like, yeah. So or insert 0. That's my insert 0 object, and then I do the same thing with my. And of course, I have to put the parentheses, otherwise it just measures how long it takes to append reverse object, and I call my append reverse. Yeah, and then you should see a difference between these two ones. And you see it gives me back this. Yeah, and the equal sign has to go this way, so otherwise it's yeah. So. Yeah, time just gives you the normal time. Time runs it exactly once. This is just the time, no? This gives you the time, which is this is like the same as in the command line. The time gives you the wall clock time. This is the wall clock, the time that actually is you can measure, and this is how much CPU you use. So wall clock time and CPU time is not necessarily the same. So it could be even if you use multi-core, then the CPU time is bigger than the wall clock time. If you use 8 cores, theoretically the CPU time could be 8 times as much as the wall clock time, which is not possible theoretically. And you see here that the user has about 1 microsecond, and here this total is 3 microseconds, but it took 4 microseconds because there are some idle time. So the CPU is not always 100%. Yeah. That's time. Time it is internal, and you see now you have different measures, and you have to look at the unit. It's important you have the unit. This takes 25 milliseconds, so 2.4 to the minus 5. Yeah, millisecond is minus 6, and this is microseconds, so minus 9, so it's 1.4 to the minus 7. Yeah, there's 2 orders of magnitude. This is a bit hard to calculate on your head, but now we have this object. I can say this is this one, and I have the average, which is the average time in seconds. So this is the one in seconds, and I can divide it by this average time, and I do get the ratio. Now I know it's 174 times faster. This will be really hard to do in your head, I guess. So it's much better to do it calculated. So you have this rich object that has all the information. So this one has all this. Click the right thing when you talk. This has all this information, and you have all runs. So this gives you all the raw. There's all the raw measuring data that it took. Yeah, I said it's about a second, but it's only a quarter of a second in this case for the 10,000, and then you divide it by 10. If you divide it by 10, then you get to this runtime. Yes, yeah, you can force pretty much everything. So if you look at the help, then it tells you all these options. So you can set all these numbers. See, these are the numbers. And this is the number of execution, the 100 million or 10. Yeah, This is the repeats, which defaults to 7. So this is dynamically determined. Yeah. So you can set this one, then you have the repeats, and you can also measure, decide which functions used. It uses time. You can use different functions. So there might be, it's much better now, there used to be different timing functions on different platforms that had very different meaning. Yeah, very often it's a time relative to the 1st of January 1970 or something else. Yeah, depends. And they might have also different degrees of granularity, so fine they can measure. Yeah, there's a new time you can have nanoseconds measurements and so on. So you can set a lot of things. This is interesting quiet. If you do a lot of measurements, you get a lot of output. You can suppress the output, so you won't see anything printed to the screen. Yeah, and this is what I used, and I get an instance of this class time result back. That can be useful. So time it is something can be very quick. Now you see there's a big difference. Now the question, why is the big difference between this function and this function? It looks so similar. What's the big thing? Why the big difference? Yeah, so if you don't know, you can use yet another tool to inspect things. It's called prun, which is using the Python C profiler. So if I say insert 0, it's called, yeah. So it doesn't complete here for some reason. And now it runs it as a Python profiler and gives you the standard output, yeah. So this is just a nice interface to the Python profiler. You can import C profiler, make an instance and do things. And here it's doing it for you in a sensible way, and you get the output. And it tells you, okay, where does the time go? And you see this insert method is swallowing all the time because this is a cumulative time for the insert method, and it's pretty much more than 90% of the time goes into the insert method. If I do the same thing, prun append reverse, I think it's called, yeah, append reverse, yeah, then you see now this append method is much faster. The cumulative time is much faster, and the rest doesn't consume a lot of time. Then you see the big difference between insert and append. So append is efficient, so Python lists always have a lot of space at the end, so it is pre-allocated, you just write in there, when it reaches a certain size, it makes it bigger. Yeah, so we have this example, if you have 100 million entries, it has like 100 allocations, not much. Let the list grow. So the list is always a bit bigger than it needs to be, so you use a bit more memory, but you're much faster because when you insert it, every time you insert, you have to rearrange the whole list, because everything is in order, so you have to say, okay, copy the whole thing and put in the first, copy the whole thing and put in. This is the most inefficient way to do it. And that's why if you make this bigger, you can, if you make it 1 million, then it takes hours for the first one. Because the bigger it is, the more expensive. The every time gets more expensive to copy. Yeah, this is a big anti-pattern. If you don't know, this would be a good way to find it out. And this prun has a lot of options. And also you can produce output files, and these output files can be post-processed with nice libraries that give you nice, colorful pictures, different types of pictures. Here's easy enough to see it. If it's more complex, it's really hard. When you get nice, different circles or squares, different pictures, different colors, and you see what function is using what. This prun C profile is only on function basis, so you cannot look inside a function. There's also a line profile on Python, which is pretty slow. You can also use line profiler with Magics. I haven't shown this here. You need to install it. This would be something else out there. Good. It's time, or we only have 20 minutes. So you can also check what's defined. There's another command. So if the people that come from MATLAB very often ask this, you can have a who. And that's everything I defined. Here comes out, and you also have a who's. Then you get the table of all these ones with the data type and if potentially the value or the size or some other kind of interesting information about this object. Yeah. So of course you cannot display a list with 100 million elements. It doesn't make sense, but it tells you if you have a list of 100 million elements, and then you see. Yeah. And you can also, if you want to have, you don't need to parse it. This one gives you everything in a list, and you can use it directly. Good. Okay. This is a very quick tour. There's many, many more things you can do. So if you go through all the menus, you can find a lot of things that I don't need to explain, pretty clear what you can do here. There's also a long help. You see the help. If you want to know something about Python, you go in here, and this brings you to the Python web page with the right version of the notebook. So this is selected according to the version of the notebook. So if I would use a 3.10 notebook, it brings me the 3.10 help and so on. This is the same, exactly the same thing. This is just the help from the python.org, but also you have help about many NumPy, SciPy, Matplotlib, SymPy, Pandas, so very commonly used scientific libraries where you can see more tutorials today and tomorrow about some of them. And then you come to the help page. And if you want to know more about Jupyter itself, there's a lot of references here about Jupyter. There's also contextual help, show shortcuts, and you get, these are the standard shortcuts. If you want to change them, yeah, these are standard shortcuts. Yeah, if you can remember all of them. If you don't like them, you can go to settings. And here you have a lot of settings you can set. For instance, I always set auto-close brackets. I forgot to mention this. Then you get automatically, when you try the opening parentheses, close it. I think the newest version does it by default. If it's not enough, you can say settings editor, and you get to this editor here. And you have a lot of entries, and you get the graphical one. If it's not good enough, you can also go to JSON and get the same thing as JSON. Where's the JSON? Open it somewhere? Yeah. No? Also, I have to. So, okay, if I select one, then this is how this looks like. This is a JSON. So if the GUI doesn't do it for you, then you can use a JSON. Also, it's easier to copy paste settings from one place to the other if you like. And you can set pretty much everything. You can spend a week here fiddling with the settings you want. We don't do this, but a lot of things can be done. There's also a CSV viewer. So if your file has an extension CSV, then it shows a nice table and a lot of other viewers for different file formats here. They can be useful. You can also have extensions for HTML5 files and things like this. So,
How did you get there again?
so you go to Help, Settings, and Settings. To go to Settings, Settings Editor.
All right.
Yeah. And then you can, a lot of things can be done here. So if you like a dark theme, you can change it here. Otherwise, you can do very sophisticated settings via the GUI, or if it's not good enough, via the JSON. So those things usually you do once, and then you have to let it sit there for 2 years, and you totally forgot how you changed it. Good. Okay, this is some basic features. There are many more, but I should give you a good idea, and always you know where to look and how it works. Now, a few things about use cases. So notebooks are great. I use a notebook every day. I always have many notebooks open and do a lot of things in notebooks. I do all my teaching in notebooks, and I think for learning notebooks are great. Whenever you want to explore something, how does it work quickly? I open a notebook and I try it out. If you develop a bigger project, then you shouldn't do it only in a notebook. Then you have to switch to an editor. But you can always combine both approaches. So you write your code in a file, and then you import. And then you import things, and you can work with it here. Importing is a bit a problem. So if you have a notebook, let's make a new notebook. We can do it like this, yeah. So if I have a new notebook, yeah, and if I say import add, then I have my function add, and I get this add function is right there. If I define another function here, and yeah, so now I go back to my import, and I re-import my add, and I look at my sub function. It's not there. Yeah, because imports happen only once. So how does it work? We import, when Python imports something, it puts everything into the dictionary, a very big dictionary. It's called sys modules. Yeah, that's just a dictionary, and now my function is there. So the first time it imports it, it just looks there, finds it, and reuses it. So I'm in a running Python process. Typically, you don't change source code in a running process. Here we do. So one solution would be kernel restart and run all cells, and then There it goes. Didn't I stop? Maybe I'm in.
You are editing at 2, that's fine.
Add 2, okay. I'm in add 2, and then still add 2. I have to execute everything. Yeah, and now it's there. Yeah. So this can be very confusing because you think you have changed it and then it doesn't change. Yeah. You know, you change your file. Has no effect. That you just realize you have 2 files with the same name in different directories, and that happens often. If you don't like this, you can say load extension, auto reload, load, and then you can say auto reload, and you have different modes, and I use the mode 2, which of everything reloads. And now I still have to now say kernel, have to restart everything, but now I can go to my add 2 and add yet another function. Yeah, and now I can say add 2. I have to execute the cell, and then it's there. Add 2 dot, and you see the mult is right there. I don't need to re-import anything. It re-imports everything in background. It works to a certain degree. It's not 100% foolproof. So if you have a module that imports a module, and change this module, it doesn't do the re-import. It doesn't chain it down. But if you have one module and change directly, it works. So there might be still some cases where this doesn't work. Also, if you look at this, it tells you a long explanation that is complicated. The auto reload is not easy. Yeah. Yeah, and it tells you here a long-winded thing that is not that easy. How it works, it's difficult and to explain. There might be some strange effects. Sometimes there might be something that don't work the way you support. It doesn't work for C, it only works for plain Python. So C modules cannot unload and reload it. That doesn't work. You have to only do it for plain Python. So this is something that might help you doing a few things. So one big problem is large notebooks. Very often I see people with notebooks with 500 cells or more. Don't do this. So small notebooks are nice notebooks. If a notebook is too big, chop it down. So if you want, you can actually select multiple cells and copy it back and forth. So I could, for instance, I go here in a cell, escape, arrow up, and now with arrow down, I can highlight all the cells, right mouse button, copy cells, and now I can go to my import one, and then I can say right mouse button, paste cells below, and now it pastes all the cells with all the formatting, all meta information in there. So you can take it out. Instead of copy, you can also say cut. So if things get too big, you can still, by hand, to some degree, chop this apart. Make notebooks. Whenever you can use headings, I haven't done much of a heading, so you could also use headings, yeah. Something like this. Whenever I have a heading that might be, now you can break the notebook up and put in a new notebook. So multiple small notebooks are nicer, and you can have one notebook that links to the other notebooks as a table of content. You can also, if you want to, some people, you can say 01, 02, 03, so number the notebooks if they have a natural order, then sequence, number them, and put them together. So make smaller notebooks have, the more notebooks you have, the more you have this effect of this ghost rebels like the X we had before. Those smaller notebooks are, are better. Split them up and do things. So you can select this one, have a table of content where you link to the notebooks. The other one I explained already, this out of order execution. So you have two ones you can run cells. There's many different options to run cells automatically. There's also some keyboard shortcuts here for them, or you can restart the kernel and do a few things and run this. And you can also change the kernel. So if you like, you can always switch to a different kernel, which is not possible if you only have one kernel. But now I could connect to a kernel from another notebook, and you can also install multiple kernels. So usually I run Jupyter Hub, and then you very often have multiple kernels installed. In this case, it's only one. And you can also install a kernel for MATLAB and Haskell and Fortran and C and whatever. So all languages support kernels, and you can use the same environment for different programming languages if you need to. It makes things easier. Don't have to learn a new tool for all of them. One thing is global variables. So if I do something like this, yeah, so I have a very complicated program that prints out this X. And now I do something, and I work, and I define a function. So it takes this example here, a function that takes an argument and defines y and then returns for some reason. So this is, and now if I use this function, which the first thing it doesn't use an argument, but it gives me a result. The x is not defined, the x, because now Python is using scoping rules. The x is not defined in the local scope, so it goes to the global scope, which is the notebook. And this works, and everything is nice. As soon as you copy it to a file, it doesn't work anymore, which is the right thing to do. Yeah. So we have to be careful. That happens to me very often, that you develop something, put it in a function, the notebook, everything runs, you copy it in a file, doesn't work anymore. So you have to copy in a file early to see if everything is okay and you don't have any dependencies. For this little function, it's pretty obvious. If you have 20 lines, 40 lines, it might not be that obvious. Yeah, and everything works so nicely, and then you put in a file and everything blows up. That's why it's easier to put it in the file and then do the reload thing. But this also, of course, if you define the X in here, then it's still, you still have the thing. Then you might need to restart from time to time and with a fresh notebook. Yeah. Again, the bigger the notebook, the higher likely is that you have this things. So put things in a notebook, re-import things, and work with them. Good. So I have a lot of examples. The auto reload I just showed you, I have it written out, and these are some of my recommendations. So I think we're pretty much through the material. So I pretty much didn't skip too much. Any questions? Yeah.
You mentioned at the beginning that notebook has everything that IPython has, but so how should I really see IPython?
Yeah, so you're correct. The question was that the notebook had everything IPython, so IPython is included. IPython's advantage runs on the terminal, so you can use IPython over SSH. So if you have the SSH into a machine somewhere else, there's no GUI, you can still use IPython, which is much more comfortable than plain Python. And many things work. All this commands that QuickGraph shows actually are from IPython. So everything QuickGraph shows you works. Markdown, graphics, colors work to some degree, yeah. But a lot of things cannot work because they need the browser as a display background. Yeah. So it's both tools can be useful, and IPython is fully integrated. It's using IPython in the background. It plays in it. There's not two tools, but Jupyter is using IPython. And if you look at of course you can go to version here about JupyterLab. And this is 4.0, and as somewhere even it shows you the IPython version it's using. And it's pretty much the newest. Maybe there's a 4.1 now. I don't know. It's just a few weeks old. I installed this 4 version here. Yeah, another question. You should wait for the mic, but I repeated the question.
Yeah, thanks for this super nice session. I had a question regarding the debugging functionality. Yeah, I mean, as we know, or perhaps don't know, there's this inconvenience that when entering certain expressions, they are not supported in the Python or IPython debugger. I'm thinking of list comprehensions because of the scoping. Yeah. So there's this interact command, yeah, or interactive command that can be used to enable, yeah, for example, list comprehensions in the debugger. And one thing I noticed with IPython or with JupyterLab in particular is that it can be really difficult to get out of this interactive debugging mode. So you can hit Q or exit or quit or any of these things, and you would get stuck. And very often,
yeah. So that can happen. Another one is like input is similar. So if you use the input is not designed for. Yeah. The input gives you this input window, and you type something in. Yeah, and then this kind of works. But sometimes it happens that the input window disappears, but the prompt stays. It still waits for the input, but you have no chance to input it. This is because this input is not designed for the notebook, and they try to make it work. And this sometimes you have always in every course I have one person that then say, oh, you have to restart the notebook. The only thing is to restart the whole thing.
Okay, so this is a known issue you confirmed.
Yeah, it's kind of it's difficult, and I read something. I'm not sure about the details, but it's not that easy to put these two concepts together, because input is something for terminal program stops. You type something in, it continues, and here they translate it into this window, which stops the terminal. But somehow you can make the window go away without pressing enter, and then the window is gone, but it's still locking. You see the busy command. Yes, do you see this? This means it's busy. Also shown here and down here, and is waiting for input. And for sometimes you can it's this time maybe they changed something. Because sometimes you could click in here and continue, but now if you press Shift Enter, you get this. You have to press Enter.
And do we have time for a related follow-up question?
Yeah.
So I'm not sure if it was the case in your presentation now. But I often noticed when dealing with Jupyter debugger that sometimes it's a bit unusual compared to the IPython console, where you put in your commands and where the text is displayed. So it can be that you have it above in a cell, and then the output is below in the traceback. Mm-hmm. Is there any kind of recommendation in terms of quality of life improvements for the debugging to have both the input and the output where you see it? You know what I'm referring to?
I don't know, but maybe you can. There's a lot of settings. Maybe you can change the display in one way or another. I have no idea.
Yeah, I think it depends. I mean, in VS Code is one thing. Then there's the classical notebook, and I think in JupyterLab. Could you just go back to the traceback of the debugger, please?
This one?
Yes. So you debug, you have an issue, and if you activate the debugger, the input is listed below, right?
Yeah. So if I have to re-execute, so I trigger this exception. Now it goes to the last exception, and then you have this here.
Okay. And then if you type something now,
then you
Q or A,
good.
P.
Like if now you can
Okay.
And then you have a step, which is the same thing as ending.
No, I think this is just fine. So I'm actually not really capable of pointing to the issue how it is. Maybe it depends.
This is very basic. So if you solve your problem quickly, you do it. Otherwise, you turn on your PyCharm and do the debugging in PyCharm.
Yeah, sure.
Yeah. So this is a tool for quick things, and if you have something very complicated, you're not a notebook anyway. Supposed to be.
That's true.
Somewhere else. Yeah.
No, I was just wondering if there is any kind of particular wisdom for this.
No, that's all I have.
Okay, thank you so much.
Any more questions? Yeah.
How do you install?
There's nothing special. You just install. Normally, you just open the terminal. Yeah, and then you just install. You can type exit without the parentheses here, and I just install Mamba install your packages. Yeah, and there you go. Yeah. There's nothing special. And once you install it, it's available immediately because it's there. Now, if I install it, then it should do. It's a pretty empty environment, and maybe it's not there. Maybe it's there. Yeah. So there's nothing special. There's nothing. There's just updating.
Okay. And if I would like to use, for example, old pandas version and the new pandas version, so I would like to have two.
Then you make two environments. So that has nothing to do with here. Then you create. So I use Conda, or actually I use Mamba, which is a replacement for Conda. There might be some talks about those things. Mamba info env gives you a list of all these environments, and I have a lot of them. There's a lot of old ones I had to show away. You see, I have a lot of environments, and these ones, then you have two environments. Because I do a lot of experiments with different architectures and stuff. Yeah. So if you make environment, the only thing you need some space on the hard drive, but typically they symlink most of stuff. So, but recently I cleaned some old things I don't need, and I've cleaned 40 gigs of my hard drive from packages I don't need anymore.
You can also show Python virtual environment, because then you always have
Yeah.
the thing next to your source code.
That's a virtual environment. So I use the Conda-based one. You can use a pip-based one. You want. The Conda one is a bit more comfortable and also has transactions and a few other features that are very useful. Any more questions? Yeah.
What do you think about things like Quarto or NBDev? Do you know those things?
NBDev, I used NBDev for a project. So NBDev is and it was a question if you use some IDE kind of features in the notebook, and PyDev or NBDev is one of them that can be helpful. They have a whole framework, so you write all your classes and all your tests in a notebook. You write a class, and the test is just some asserts, and you write your documentation, and then it generates a Python package out of it. It generates your documentation with Markdown and upload it to GitHub, and you have your tests in there, and it generates everything. And it can be useful. I used it for one project 2 years ago. It's nice, but it's very opinionated, and I like to use things, but it doesn't support things. It uses some other tool, and it has to upload to GitHub. If you don't want to use GitHub, you want to host your own, then you have to work against this kind of framework. If you want to go with a framework and do exactly the framework does, and works pretty nicely. And you have literate programming, so everything is a notebook. You write your explanation, you write your tests, everything in a notebook, and it generates everything from one source. Maybe if people put more things in there and make it could be an approach. You could use it, actually. So I haven't used it for new project posts. All my other projects are not set up like this, and I don't want to change them because they work. Yeah.
If you're interested in this, I'm regularly using it. This year I started digging into it, and it's quite useful actually for certain settings.
Mm-hmm.
Yeah, I went to give a course on that on my institute, and I had to pick it up again because I did like this a couple years ago.
Yeah. So maybe it developed. I cloned it, and I still get some. I always get from once in a while I get a security problem. I think because they use all Node.js stuff, and they always get security things. But otherwise, I haven't used it.
I think most of it is actually this Quarto thing. They just
I don't know.
Like the GitHub integration with this Quarto. Quarto is the base of that thing, and it's less opinionated.
Okay, maybe we can talk about it. I have never heard about it, so it's yet another thing I haven't heard about. Okay, any more questions? I think we're over the time, but if you want to sacrifice a bit of a break. Any more questions? So I will be around for the whole conference, including the sprint, so if you want to grab me during the thing. I also have a booth out here, so you can reach me maybe there. Otherwise, thank you very much for being here. I wish you a nice conference.